video, I'm going to talk about the law of sines, which is a tool you can use to solve the angles and side lengths of a triangle. First things first though, the law of sines only works for non-right triangles, so I'm going to mark that off here. Non-right triangles. For instance, if angle B was 90 degrees, then you wouldn't be able to use the law of sines, and instead you'd have to use something like Pythagorean theorem. If your triangle has no right angles, like ours, then you're good to go. So for triangle ABC, the capital letters A, B, and C represent the angles of each of the vertexes. Angle A produces side length little a. Angle B produces side length little b. And angle C produces side length little c. Given these values, the law of sines states that the sine of angle A over little a equals the sine of angle B over little b equals the sine of angle C over little c. You can also write this as the reciprocal, so you can flip this so that A over sine of A equals B over sine of B equals C over sine of C. So these two things basically represent the same sort of thing, and you can choose which one you want to use based on the problem you're solving. As I'll show you in a little bit, sometimes it's easier to put the sides on the bottom. It reduces the amount of algebra you have to do, and sometimes if you know more angles, it's easier to put the angles on the bottom. Alright, so we're going to hide these, and then we can start one of our first example problems. You'll encounter two types of problems that you'll solve with the law of sines. The first type of problem that we're going to look at is a side angle problem, or SSA. As the name suggests, in these kind of problems, you'll be given the value of two sides and a single angle. Then you'll be expected to solve for the missing values. In our example, we have C equal to 30 degrees, little c equal to 9, little b equal to 15, and then we don't know any of the other values. In this case, when you have more sides than angles, it's best to put the sides on the bottom of the equation. So we're going to start by looking at what we have. We have C's and we have one B. Since we have no A's, we're going to leave that out for right now. So step one, we're going to solve for big B. And we're going to start by doing sine of C over C equals the sine of B over B. Okay, from here we can basically just plug in the values that we know. So sine of 30 over 9 equals sine of B over 15. Then we can multiply across to 15, so we'll have 15 sine of 30 over 9 equals the sine of B. And if we do the inverse sine of this, cancel that out, plug that into your calculator, and B is going to come out to equal 56.44 degrees. Cool. So we'll add that to our diagram. Second step is actually not going to use the law of sines at all. We're just going to use our knowledge that the internal angles of a triangle should add up to 180. So we have two angles right now, and we can subtract them, 30 and 56.44, from 180. When we do this, we find out that angle A equals 93.56 degrees. Okay, so we're getting closer. Now we just have to find side little a. For step 3, since we know more angles than we know sides, we're going to put the angles on the bottom. So we're going to have A over sine of A equals C over the sine of C. Then we can plug in what we know. We don't know little a, but we do know big A, 93.56 equals 9 over sine of 30. Then if we do this math, 9 over sine of 30 times the sine of 93.56 degrees. Plug that into your calculator, and you should get that side A is 17.96. 17.96. So that is the first use of the law of sines. Let's move on to another layer. The second type of problem, as you may have guessed, is called an angle side problem, or AAS. In these types of problems, you're given two of the angles, one of the sides, and then you'll need to figure out what the other ones are. So again, we have angle or triangle ABC. See? In this case, angle B is 35, angle C is 105. We know little b is 7, and that's actually all we know. So in these problems, we have more angles than sides, so we're going to start off by putting the angles on the bottom. Before we do that, though, we can even figure out what this angle is by just subtracting the existing angles from 180. So let's do minus 105 minus 35, leaving us with A equals 40 degrees. Gotta make my eraser a little bit smaller. 40 degrees. Cool. Now we can move on to step 2, which is going to be finding side little c. In this case, we're going to use this equation because we know both b's and we know one of c's. So we have basically everything we need to know. Now we'll plug in the values. C over sine of 105. Pull this out. C is going to be equal to the sine of 105 times 7 over sine of 35. Plug it into your calculator, and then you get 11.79. So let's get rid of this. 11.79. Cool. Final step, we need to find little a. Again, we have more angles than sides, so the angles are going to go on the bottom. A little curly there. I'm going to do c over sine of c equals a over the sine of a. Plug in what we know. 5 equals a over the sine of 40. A is sine of 40 times 11.79 over the sine of 105. A comes out to be 7.84. So let's get rid of this. 7.84. And what we've done is solved for all of the angles and the side lengths of this triangle. That's a brief intro to the law of sines. It's super useful. In the next video, I'm going to show you how you can run into some more tricky cases where the law of sines might not be adequate. Alrighty, thanks.